In this video, we will learn how to reverse a linked list using both recursive and iterative algorithms. We will also talk about their trade-off analysis using LeetCode 206, and it's an easy problem in LeetCode. Hello, my name is Imran, and I'm working as software engineer for last 12 years. I solved more than 200 LeetCode problems and passed technical interviews in multiple FANG companies. If you are new to this channel and preparing for tech interviews, consider subscribing. Let's go ahead and jump into solve this problem using recursive approach. So we are given a linked list, and for linked list, you are given few nodes like 1, 2, 3. And each of the node actually points to the next node in the list for single linked list. We already solved this problem in other videos. I will link that video in the description. And to use it solve recursively, what we want to do, we want to make sure for each of the node, we recursively reverse the linked list. So for this 1, 2, 3, we want to make sure the return will be something like 3, 2, and 1. And so if you can take a look at these algorithms, so we write a recursive function here. And for the base case, if our head is null pointer, we'll just return the pre value, and pre is actually another parameter for this recursive call. And from the main function, we will return call the function with two values like null pointer and also the head. And we will get the tail from the given list. So what we can do, so for the first recursive call, this is our tail. And this is our head. What we want to do, we want to get the tail pointer, and then we want to update the head dot next. So this head dot one dot next. So if we have one here, so let me just make the changes is as here 1. So we want to point the 1 to the pre, which is a null pointer. And then what we want to do for the head dot next, we update this part. Just make it like this. And we want to reverse the whole tail part, right? So this is our reverse of this whole tail part. And we will return this node as the final results. That's the recursive approach to solve this problem. Main thing to consider when we are solving using recursive algorithm, the runtime complexity would be order n, but you need a recursive stack, which might be order of n. So the space complexity for this problem will be order n. And you can watch into detail in the other videos. Let's talk about the iterative approach, how we can solve it using the iterative method. I'll just comment out this whole part. And also this part. So when we are trying to solve using iterative approach, we need to make sure we are updating the pointer in a very specific manner. So let's take a look at this node again, 1, 2, 3. And initially our pointer is like this way, 1, 2, 3, and 3 is pointing to the null pointer. Now, if we want to make it a reverse order, then your 3 needs to point to this 2, and 2 needs to point to this 1, and 1 needs to point to a null pointer. So that's the final result, what we show it in a, and we will, so this will be a head pointer in a recursive approach. So what we want to do, we'll write a loop to update all the pointers, and to get that, at first we will use few variables. So we'll use actually a variable pre, and then a current pointer, and also the temp pointer. So what you want to do for the pre, we will point to the null pointer here, just initialize as a null. Current will point to the first head pointer, and temp is point to this pointer. And what we want to do in the loop structure, we want to update all the pointers, so that this current basically update this pointer to current to be pre, temp to be car, and basically move this pointer one at a time to the right side. So let's go ahead and implement this one. So we'll write the first the initial case. So if your head is null, or not head dot next, in this case we'll just return the head. What this does basically, if we are given a null node, something like a null node, or just one node, we'll just return the same thing, because if we reverse it, this will be the same impact. So we need pre and car, and pre will point to the none, and then car will point to the head. We need a temp variable, which will actually point to the head dot next. And what we want to do, we want to go to something like our temp pointer until it reaches the null pointer. We will going through this loop. Each of the part we want to do card dot next. So your one dot next needs to be null. So it basically needs to be a pre. And then p needs to be, so we'll update all the pointers, move all the pointers in the front. And then temp equal to temp dot next. And when we are outside of this loop, we just need to do car dot next equal to pre. And finally, you can return the current node. So in each step, we are basically update all this, reversing all the pointers. So car dot next will become this one, pre. And then we move all this pre to one level down. So pre will come to here, current will point to here, and then temp will point to here. And when we are end of this loop, what we want to do actually, the final current, that means the value of the current, we want to put it as this pre-pointer. And finally, we'll return this 3 as a head. So that's how we use it actually using the recursive approach. Let me submit this guy. And yep, that looks good. So let's talk about the runtime complexity and space complexity for both the algorithms. So for this problem, if we are using the iterative approach, then the runtime complexity will still be order of n, which is true for both the cases, right? So let's draw a table to understand what would be the main issue, right? So there are two things, right? So we have a recursive approach and then iterative approach. And this is the table we want to fill. So at first, for the case of time complexity, if you're considering time complexity, then both will be order of n, recursive approach and iterative approach. When we are considering the space complexity, this for the iterative latest approach, we are using only 3 variables like pre, current, and temp. So this will be order of 1. But when we are considering the recursive approach, we need a stack, so which will be order of n. So these are the main advantage and disadvantage using these 2 different approach. So recursive would be more space consuming, but it's easy to write when you are writing recursive algorithm. And if you can solve it in iterative way, that's even better. If you like this video, now you can watch the other recursive video, LeetCode 206. I will link that into the description, or you can watch it here. Thanks for watching.